So in the previous video, we discussed that if a non-zero integer has its exponent 0, its value is actually equal to 1. And we learned it how. But we said that there's another way to prove this, that a non-zero integer having its exponent 0 is actually equal to 1. And so we are going to discuss that in this video. Let's do this. So those of you who haven't watched this video, for them I'll put the link in the description box below. Please watch that video so that you can better understand here what we are discussing. So we have already proved that a non-zero integer having its exponent is equal to 1, but let's look at a different proof. So a is an integer and that is not equal to 0. Imagine that we have a to the 5th power. Now this a to the 5th power can be written as a times a times a times a times a, right? Now if I write a to the 4th power, what will this be? This will be a times a times a times a, right? A multiplied with itself 4 times. But if you look, this is actually what? This is actually a to the 5th power divided by a. And how? What is this a to the 5th power? A to the 5th power is a times a times a times a times a. And if you divide this with a, what do we get? We get a times a times a times a. That is, we are multiplying a 4 times with itself, and that is what exactly we have written here, right? So we can say that this a to the 4th power, when written in this form, is actually equal, it's coming from this operation, division of a to the 5th power divided by a, right? Now similarly, can we say that this a to the 3rd power can be written as a times a times a, and this will be actually equal to a to the 4th power divided by a. And how? A to the 4th power is what? A times a times a times a, and if you divide this with a, then you are getting a times a times a, that is, a is being multiplied to itself 3 times. That's exactly what we have here. So a to the 2nd power will be a times a, and this will be actually equal to a to the 3rd power divided by a. And why? Because this a to the 3rd power is actually what? A times a times a, and when we divide this with a, what do we get? A times a. That's exactly here. So a to the having its exponent as 1 will be what? Exactly 1 only. But this can be written as a to the 2nd power and divided by a. Why? Because a times a divided by a will be actually what? A. That is what here. So can we say that a to the having its exponent 0 to the 0 power will be actually equal to, from this one, from this pattern, will be actually equal to a having its power 1 divided by a, right? Now what is this a having its power 1? That is actually equal to a. This is actually equal to a only, right? So this is a divided by a, and this is actually what? 1, because this will be 1. So from here we can see that a non-zero integer, is actually having its exponent at 0 is actually equal to 1. This is the proof. This was the first proof, or one of the proofs, and this is another proof. Okay,